Hello, class. I'm going to go over that second problem in section 10.1 that has to do with, again, scatter plots and correlation. And so it's an example from the ebook. And I asked you to print, you should have printed that page out. So in your module related to your quiz 2 module, you have saved PDFs. And in there, towards the bottom of that list, related to the chapter 10.1, you should see a PDF there that has these handouts that I'm going to go over, and has a page that has these two problems on that handout. Okay, and so I'm going to show you that page in just a second. I went over it earlier in the previous video when I was going over the first example, that 14, the forest fires and acres burn. And so I went over that handout, discussed that handout. Okay, so just a reminder, this is the review guide for the quiz 2 study guide. It'll have 7 problems. It'll be timed for 65 minutes. And you want to have this decorated. You can either decorate this, the front and the back, or you can create your own from scratch, but you are limited to a one double-sided page, and then you want to upload that before you start your quiz. Um, in your Canvas course, you should see like a quiz number 1, like review guide, upload quiz number 1 review guide. So, and let the titles guide you as you upload that. But there's a difference between the quiz number 2, study guide, right? You're making a toolkit, you're making a cheat sheet, you're making a note page, right? That you're allowed to use during this timed quiz. And then the other thing you'll be uploading, you want to upload that first, but then the other thing you'll be uploading, and these are requirements, is your work. So I will make available to you like a quiz template where you will show your work on and upload that. And that needs to be turned in within 15 minutes of you submitting your quiz number 2. Okay. Um, and so down here we have chapter 10, section 1. So what we'll be doing is we'll be stating the hypothesis. We'll be selecting the correct scatter plot from your provided data. We'll be computing the correlation coefficient using our TI-84 plus graphing calculator. And always you want to round to whatever Connect Math specifies, your homework platform, whatever your homework platform specifies what to round to, you want to round to that. We're going to find the correct probability value. We're going to test its significance against an alpha level that they'll assign to us. And the alpha level can constantly change in your homework and on your quiz, from problem to problem. So you need to pay attention to the alpha level and use whatever they are assigning to you in that decision rule. And then you determine if you're going to, if the null hypothesis is going to be rejected or not. And then depending on whether you reject it or not, then you want to explain the relationship. Is it significant or not significant? Okay. So this is found in your, well, it has here, I have here the sections. This was from 2. So yeah, this is 10.1. So I do have that there. I'll just put that here as well. Okay. And then with your course, we're going to, down here, we're going to our SLOs, our course outcomes that are listed in your syllabus. This is relating to solving correlation problems. And we're also performing hypothesis. We're doing a two-tailed test using our graphing calculator. So we're performing hypothesis testing, and we're using statistical methods. So that covers that section there. Okay, so last time when I, in the part 1 video, I worked this problem with y'all. You remember that? I worked the forest fires and acres burn problem. So now I'm going to work this problem with you, the state debt and per capita tax. So I went ahead and I made another copy. I have a printer at home. I went ahead and made a fresh copy. That way you wouldn't get distracted by this previous problem. And so let me just enlarge this. Okay, so these are all the things that we're going to do here on your homework and on your quiz, okay? So the first thing I want you to do is they want you to draw a scatter plot, and they want you to notice, like, are you going to notice any kind of a positive linear relationship or a negative? Are you like walking upstairs, or are you walking downstairs? A negative linear relationship. So you just want to see if you see any kind of a relationship taking place. So you're going to scope that out first. And so on 16, it says state debt and per capita tax. And an economics student wishes to see if there is a relationship between the amount of state debt per capita and the amount of tax per capita at the state level. Based on the following data, can she or he conclude that per capita state debt and capita state taxes are related? Both amounts are in dollars and represent 5 randomly selected states. So you see 1, 2, 3, 4, 5. And then they're just letting you know that they're also going to use this exercise in a future section. Okay, so yeah, so we're looking at, here are our two variables, our x variable, our y variable, and we're trying to determine if there's a relationship between these variables, okay? And so we're going to put the data for the x's in L1 the column, put the data for the y's in the L2 column. Okay, so to remember what to do for that, turn on your calculator here, and then just go, if you have anything there, that's fine. Just go to stats, and then go to this edit, edit. So you want to hit the enter button there. Okay, and then I guess I could make a note of that here. So I guess I could put that here. Let's see. So you go to stat, and then you go to edit, edit, and then you hit enter. I'm pressing stat here. Okay, and then you're going to have to clear the L1 and L2 columns, and then you're going to have to enter your data. Okay, so when I do that here, remember how to clear, you're going to have to use this backspace, back this. Remember, you want to use this up arrow here and go up to the top and hit clear. Please don't hit delete. If you hit delete, you're going to erase, remove your column, and it's difficult to restore that. It's not so simple to restore that. You'd have to do a second insert and then tell it what column to insert, like second number 2 or second number 1, depending on which one you remove. But oftentimes it doesn't come out in order. The columns are like a little bit out of order when that happens. You might have to do a reset or turn it off and turn it back on, but it oftentimes it takes a while to put it in order. Like right now the columns are in order. So just be careful, okay? You want to hit clear. When we do use delete, it's to, if you type something in wrong, like you type 55 instead of 51, then you can use delete, or you can just type over it, okay? So just be careful. So I went to the top and I hit clear and then hit enter. Okay, so so right here when you clear L1 and L2 columns, I'm basically going up, and then I'm moving back and forth, right? Depending on what columns I need to go to. So I'm back basically doing that. And then I'm also making use of clear, okay? And okay, then I come over here, go to the top. Oops, I want to go to the second column. So come over here, go to the top and hit clear, enter. Okay, and then start entering your data. And there's only 5 for each. So enter those. Looks like 1924, 907, 1445, 1608, 661. Okay, go to the second column. 1685, 1838, 1734, 1842, 1317. Okay, and then just review them. There's only 5. So let's see, just review them. Okay, so they're the same. Okay, everything's double checking, everything's the same. All right. Okay, so now we need to create, we're doing a skybox. So you want to make your window. And so I'm going to make a note of, let's see, how do I write it? The smallest, right? I mean, look, I'm going to take a look at how I had this set up, because when you do your quiz template, you will also have this set up similarly. So you want to fill in those blanks. So don't leave that blank on your quiz template. But I do start off with the smallest X. Just also the largest X. And then I also want the smallest Y. And then I also want the largest Y. And then I have my window. And you can remind yourself of that too. See right here, your window, hit your window and see that that's where I get these from. So my window is an X min, X max, X scale. So on your template, you're going to have these already created. So this is taking time because we don't have them created, but on the quiz template, you'll have that created. All right, so the smallest X looks like 661. The largest X looks like 1924. The smallest Y looks like 1317. The largest Y looks like 1842. Okay, so just get so I can get a second on that. Can you double check that? Make sure that's right. Okay. All right. So then when on our X-Men, you want to pick something smaller than the 661. Okay. And if you want to use 0, you can. Oftentimes I'll use 0 for that. Okay. And and that's okay. I'm going to use 0. I'm just looking ahead. See how I have this here? We're going to check our work with that. And you can see on their X's, see their X's? They actually went with 600. Something smaller than 661 is 600. So they don't want all that empty gap. See how they don't have a big gap there? See that? We're going to have a little gap because we start with 0. And that's okay. Something bigger than the biggest X 1924. So you can put like 2500. Okay. 2000 is just cutting it short. You want to be kind of generous with your extra amount. So 2,000 is, I guess it's okay, yeah, but I'm going to just do 2,500, be generous with my space. And then on my X scale, your scales can be, these are increments. So your X scale have to do with increments. Increments. Okay, so like each tick mark, right? Each tick mark. So like each tick mark, do you want each tick mark for X to be 2, 4, 6, 8, 10, 5, 10, 15, 20, 25, 30? Do you want increments of 10, 10, 20, 30, 40, 50? Do you want increments of 100, 100, 200, 300, 400, 500? So what do you want increments of? So if you look at your X values, look how they're fairly large, and they're fairly large. See, that's over 1,000. That's pretty close to 1,000 also here. So I think I would feel comfortable with increments of 500. I have used in the past 500, and that means that the first one would be 500. The second one would be 1,000. So 500 plus another 500 is 1,000, plus another 500 is 1,500. So each tick mark would be increments of 500 on the x-axis. Okay, so we're talking about the x-axis. So when we do our scales, you know, we do our scales and our x scale and our y scale. So when you say increments of 500, that's kind of what you're saying. 500, 1,000. 1,500. That's kind of what you're saying on that, increments of 500. Okay. Now on the Y min, the smallest Y min, you, if you wanted to, you could put 0. And so the thing is that this is very large. It's 1,317. So I actually made my Y min actually 1,000. In the past examples you see me with my or scatter plots, I've usually used 0. So you saw over here how I used 0. And of course this was only 45 and 15 on this previous example. But see, this is 1,317. So if you put 0, that would be fine. You're just going to have a big gap between, you know, your starting point and when your x and y axis intersect. You can see here the textbook, they started off with 1,300. That is smaller than 1,317. They started off with 1,300, and then you see 1,400, 1,500, 1,600, 1,700, 1,800. So they looks like they did increments of 100s, the increments of 100s for the y, but they started off, they didn't start off at 0. They didn't start off at 0, 100, 200, 300, 400. They started off at 1,300. But it looks like they use increments of 100. And we could do the same also, or we could do increments of 500. And I think I use increments of 500 as well. The WiMAX, something bigger than your WiMAX, you have 1842. So you could do, again, like 2,500 or 2,000. I'm going to do 2,500 or 2,000 would be fine. And on the Y scale, I went ahead and did increments of 500 also. Okay. So, and that's fine. Now you can see here on their scale, if you subtract 900 minus 600, that's 300. See, 1,200 minus 900. That's, so they did here. They did on their X scale. They did increments of 300. So 300, 600, 900, 1,200, 1,500. So they did increments of 300. And then on their Y scale, they did increments of 100, 1,300, 1,400, 1,500, 1,600. So they did increments of 100. and then they started off X-Men and X-Men and Y-Men. X-Men, they started off at 600. Y-Men, they started off at 1300. Okay, and that's fine. Okay, that's okay. And this should work out also. So when we come out over here, let's change that now. So come over here and change that. So you're in your window, and then go ahead and put 0, 2500, 500, 1000, 2500, 500. And remember, always leave your X resolution as 1. So I'll make a note of that here. I never had to change, leave alone this X resolution. I've never had to work on changing that. Okay, and then we should be good to go. And once we hit graph, we should be fine because we did that section on scatter plots. We should already have our first scatter plot turned on and set on the scatter plot, and we told the data it's in the X is in L1, the Y data is in L2. So as long as you haven't had to reset, that should be fine, and you would just hit graph and you should get a picture. Oh, and now we get like a lying a best fit. That wasn't happening before, lying a best fit. And that's because that happened because in the previous video when I had you uh let's see where that's at. That's because in the previous video I had you, now this is a yellow, kind of a yellow sheet. Yesterday it was like a white sheet, or last time it was a white sheet, but I had you press second catalog, which is on 0, and I had you use the arrow key to scroll down to diagnostics on. It was alphabetically, A, A, B, C. You had to go all the way down to the D's and turn diagnostic on, not diagnostic off, but diagnostic on. And then you had to hit enter and hit enter. And by doing that, that allows this lying a best fit to also get turned on. Okay, so and this is helpful because you can see here that uh, that this is you don't see like a positive linear relationship or a negative linear relationship. You see you don't have any of your points ordered pairs that go through the line of best fit. So that means they're kind of scattered all over the place. So it looks like we don't have a relationship. Okay, so that gives you an idea of where we're going um, with, is there's a relationship between our X and Y values, between our per capita depth and our per capita tax. But then you need something stronger, and you are able to produce something stronger with statistics. It's the beauty of the Pearson correlation test. So I'm gonna read this comment to you here. I have this little article that I printed because we're using this to teach about two-tail tests, and it uses the Pearson correlation. It's a Pearson correlation test. It's a form of a two-tail test. So it says here that the correlation coefficient, which they call rho, the Greek letter rho, it's a popular statistic for describing the strength of the relationship between two variables. The correlation coefficient is basically what it is. It's the slope of the regression line between two variables when both variables have been standardized by subtracting their means and dividing by their standard deviations. So the correlation ranges between plus 1 and -1. And that's what we talked about, remember? +1 and -1. If it's hovering around 0, then that's not a strong relationship at all. But if it's close to 1 or close to -1, that's a strong relationship. So last time we had this R value of 0.771. That's a fairly strong positive linear relationship. And then we also saw that, line of best fit, it looks like you could draw a line. If you had a ruler, you could probably draw a nice little line through most of these points or several of these points. Looks like you're kind of walking upstairs. So we saw a relationship between the forest fires and the number of acres burned. And unfortunately, we're actually seeing that what's going on. It's so sad what's going on in California. All those number of fires, as those fires are more and more increasing, they've had the most acreage ever burned ever. It's in the millions of acres. It's very unfortunate. And we wish that it would rain. They really need the rain um, to help with that. Lots of rain to help with that. Okay. And so this is what we're working on here. Let's see if I was going to say anything else from this article that I was looking at. Mm. Yeah, this is they're talking about that yeah, they're also talking about that they're talking about the test procedure, and they're using the null hypothesis and the alternative hypothesis. Okay. And it's a two-tail test. So I didn't highlight that, but it was right on with what we were doing. Yeah, so that when we do this two-tail testing, and let me see if I can go to this page here in your workbook. Yeah, so when we do this this hypothesis setting up the hypothesis, and this is set up for two-tail testing. Yeah, so when we use that procedure there, this is the most common selection. It yields the two-tail test. So we use this option when we are testing whether the correlation values are different. But you do not want to specify beforehand which correlation is larger. Okay. And so that's right on with what we're working with. So that was just a little extra input there to put inside there to include. All right. So it doesn't look, oops, my graph turned off. So it doesn't appear this that when we draw the scatter plot does not appear to reveal like a relationship. And if I can see if I can find my 2.4, see if I have my 2.4 handy here. I do. So it's kind of like this idea, see no relationship. So no relationship exists when there is no discernible pattern of the points. Okay. So the scatter plot does not appear to reveal a relationship. And they do have a picture here. I left these here on purpose so we could kind of check our work, but let's see that's kind of this is kind of this right here, see? And there's that. And let's see, this is this point here. And then there's that's that point. Okay. So there's your 1, 2, 3, 4, 5 data. And then you see that they've drawn a line of best fit here. So you can see that. I'll just put that in there since we have that. They drew a line just to kind of show that you don't see a relationship going through those points. All right. Sometimes students say that their calculator didn't draw that line. And I believe I have a PDF. I think that's one of the last PDFs I have in your module for your quiz 2. Sometimes if that happens, there's a way, for some reason, if it's not showing up, there's a way to turn that on. So if you look at that PDF, you would do something in your calculator just to turn that on. It's not necessary. You don't have to have it, but it's nice because it kind of confirms. You can see when the points are, when there's a relationship, you'll see at least 2 or 3 of the points on that line. Okay, that's helpful. It's not required, but it's helpful. All right, so then the next thing we're going to do is we're going to compute the value of the correlation coefficient. Okay, and that would be R. Okay, so part B, this was to help us with A. So part B is the correlation coefficient. Now, this doesn't tell us what to round off to, but I oftentimes, this is what happens in Connect Math in the ebook. I always have to oftentimes work backwards, like look at the answer and see what they rounded off to. And so this is really light, and I'm not sure if that's a negative or not. That does look like a negative there, but I see 0.518, so I can tell that they rounded it off to the nearest thousands. But when you take your quiz and when you do your homework, the computer will tell you what to round up. It'll say round to 2 decimal places or round to 3 decimal places or round to 4. It will tell you what place value. It'll either say 2 decimal places or hundreds, round to 3 decimal places, or it'll say thousands, but it will guide you. Not like this one doesn't guide us, it doesn't say anything. Okay, so then what you need to do is, because we did the previous problem, most of this should be set up already, but you're allowed to use this sheet on your quiz. Um, yeah, you got to use it. So we already graphed the scatter plot. Now we're going to use a linear regression test. So you want to hit stats, and then you want to tab twice, okay? And then you want to look for the linear regression test. So you're going to go to stats and tab twice to test. Do you see what I did? So hit stats and tab twice to test. And then all these tests pop up. There's like, I think 1 through 9, I think, and then 0, and then there's letters A through probably Z. But you want F. See F right here? You want F. So you either do that and you scroll all the way down till you get to F and you hit enter. Or the faster way is to hit alpha and then cosine, because if you look at your cosine, see there's an F right there and it's in green. So the other way to do it is to hit stat, tab to test, and then do alpha and then cosine. And you see that also takes you there. So you have a choice. So that's what you need to do. That's what you need to start doing. So you do need to go to stats, and then you tap twice to tests, and then you want F, you want that linear regression t-test, which is found under alpha cosine. Okay, so you will always have to do that. That is required. But what you don't have to do now, the rest of this should be set up. When we did this the first time, and especially those of you bought new calculators and whatnot, or you're using your app for the first time, you remember you didn't have anything here under the regression equation, remember? And also this may not have been here. This may have been this is left tail test, this is right tail test, this is two tail test. So maybe this wasn't set. But once we did the problem on the forest fires and the acres burn, unless you had to reset it, This should all be good already, and you should just have to go to calculate. But you want to just make sure, did you put your X data in the first column, L1? Did you put your Y data in the L2 column, or did you change it to L3 and L4? Because if you did, then you need to keep up with that and change that. And the way you do that is if you put this in L3 and L4, you just hit the second button and then 3. See? And that changes it to L3. And if you need this to be L4, you just hit the second button and then number 4. Because see, if you see 4, see that's L4 in blue? And see how that changes that? So you don't always have to use L1 and L2. If you want to use different columns, you can, but then just keep up. So I'm going to change it back to second 1 and second 2. All right. Okay, so then you want to leave the frequency the same. That should always be 1, and you want to make sure this is on the two-tail test. If it's here, I'll hit enter. If it's there, or if it's here, that's a right tail test. Yeah, this is pointing towards the right. This is inequality. That's a less than. That's a left tail test. This is a two-tail test for what we're doing with this Pearson correlation test. This is requires a two-tail test here, what we're doing. And so you need to make sure the first one's highlighted. And then this should already be there. This needs to be Y1. Now, if it's not Y1, then you have to continue with this process. If it's not Y1, then you're going to tab to this section that has something else or it's blank. And then you're going to hit the vars key, which is in between this and this. So you hit the vars key. And then you're going to hit this arrow key and go to Y vars. So you see, hit the arrow key right here, go to Y vars. Okay. And then you want the number 1 function. So press enter. So it's already there. Hit enter. Hit enter. And then you want Y1. That's what it says here. And then there's little guides here. Little guides here. See, it's empty here, and now look, it's got Y1. So hit enter because you want Y1. See, and there it is, which we already had it there. Okay, now you can calculate. So now go down, hit the tab, and then hit enter and calculate. And we're looking for R. So you're going to have to tab down 4 times. So let's see, tab down 1, 2, 3. So you don't want R squared. R, yeah. So remember, R squared is this, what is that? R squared is the coefficient of determination. You want R, the correlation coefficient, okay? All right, so R is 0.517585482. And it's positive. I'm around to there's thousands, tens, hundreds, thousands. Okay, look at the number to the right of that. The neighbor, is that 5 or more? Yes, so add 1 to this. So R is about 0.518. And stop at the thousands, okay? Yeah, so I couldn't tell what this is. So that means this is an equal. It just came out real light. I couldn't tell what that was. That's an equal sign there. But they round it to there's thousands, okay? So whatever they tell you to round to on your quiz, just follow directions on that. So that answers B. And then, okay, then you want to think, okay, so now this is another idea, like what is the strength? What is the strength of that relationship? So when I go back to my notes, that has to do with this. So you have a 0.518. So you're kind of like hovering about right here. And that could go right either way, right? You're kind of in between the 1 and the 0. So you're not really sure, like, is the one when we had the 0.7 last time, 0.77 last time when we had that was definitely a pretty strong relationship, stronger, or 0.771 on that previous problem that we were looking at. I'm not sure where I had that. See, that was a fairly strong, but this one could kind of go either way, right? So let's see if I have a picture of that. Here's a picture of the 0.5. I have a little picture of what that would look like. Relationship between the correlation coefficient and the scatter plot. Okay, so you're kind of like, it could go either way, right? It's in between here. If it's hovering around here, there's definitely no relationship. So you're kind of in limbo, right? It could go either way, 50-50. It looks like it could be a linear relationship, or it looks like it may not be, right? You're kind of in between here, halfway in between. So it's not such a strong, this is, not so strong. So you're kind of like in between. It's like an in between, um, positive, not negative. It's not on the negative side. It's in between a positive linear relationship. Okay, so we'll kind of keep it at that. So so that's the purpose of that, to just think about that correlation coefficient. Okay, then you want to state the hypothesis. That's part C. So when you state the hypothesis for this uh, Pearson's correlation test, this will always be your setup here for that. So you have the null hypothesis, and this is the alternative hypothesis. And so here it says this means that there's no correlation between the X and Y variables in the population. And this alternative hypothesis means that there is a significant relationship on that. Okay, so I'm going to write that down here. This is your rho, is what that's called. It's called rho, which is the Greek letter of the alphabet, and it means correlation coefficient. And it's a population. Let me write that down if I have it here. What did I see? The population coefficient. I have it written over here. So this one's the linear correlation coefficient. And this one is more like the rho, which is the population correlation probability value. Okay. Yeah, so I was getting that from here in your handout, the p-value, probability value, okay? And I added the word population to that. I've seen that in here, okay? All right. Okay, so we have that rho is equal to 0, and then we have h sum 1, the alternative, where the rho is not equal to 0. Okay, and so we have to set those up. Okay, all right, so that's what they're going to want on the computer, and they might help you on the computer. They might have some of this set up, and then you might have to choose, like, do you put the not equal to, or do you put the equal to? So they might have these where you choose where does the equal go and where does the not equal to go. So the equal is for the null. This is null because it's got the little 0. That's null. And so no, this one's called the alternative. Alternative. Okay. All right. So that's part C, state the hypothesis. Okay, then we go to D. And D up there says test the significance of the correlation coefficient at alpha equals 0.05. Okay. And so this is where I'm going to write my decision rule. For D, we're going to use the decision rule. Okay. So we have P value, probability value less than or equal to alpha. And then we also have P value greater than alpha. Okay, and only one of these can be true. One of these is going to be true and one of these is going to be false. Okay, so the alpha level they gave us, see, we have to use the alpha level they gave us. This is another Greek letter of the alphabet. That's it that we're testing, and we're not using a table, we're using the graphing calculator. The alpha level is 0.05. And you have to be careful. You have to be careful on your quiz, because what will happen on your quiz is they will change it back and forth, like in your homework problems and on your quiz. They have the right to change the alpha level, and it's usually between two values. I have here in my notes here that identify and record the common alpha level used. It may be 500ths or it may be 100ths. That's tenths, hundredths. The choice of the level used depends on the seriousness of this type 1 error. So the book will provide you with the alpha level to use, and so you've got to change that. So don't be surprised if if you get your quiz and you got to read it and look for that. Don't be surprised if you've got to change that, okay, to 0.01, okay? All right. So now you need your population correlation probability value. So you get that from your calculator, okay? So, oh, sorry. I forgot to turn off my phone. I usually unplug my landline. I forgot to do that. Sorry. I usually do that when I try to do a Zoom video. I usually try to turn that off. So sorry. You can hear that phone ringing. Okay, so I'm going to go back up, I believe. I need to look for my probability value. I'm looking for rho, the Greek letter of the alphabet. So I'm going to go up. There it is. Can you see that right there? There it is right there. 0.37172697. So you want to write that down. And I'm going to just check that with the previous. Yep, that's what I got last time. Okay. You write that down. So 3717. Nine zero seven. Okay. And then you can you can round off. So you want to be careful on your quiz and on your homework, and you that's why you need to do your homework and pay special note to your homework because when you take your quiz is created from like homework problems. So you need to be careful because I can't remember the detail on the p-value. I don't know if they also ask you what's your probability, what's your population correlation probability value, and then if so, what round it off to a certain value. So if they do, you might have to round two things, the correlation coefficient and the probability value. So of course round to whatever they say. So I will go and round it to the nearest, you could actually round it to the nearest hundreds because this is in the hundreds, or you can round it to the nearest thousands. So however you wish. Last time I think I rounded to the nearest thousands here. Okay. Um, and if you don't, here at this point, if you don't want to round, you don't have to round if you don't want to. It doesn't look like, let's see, well, actually here, critical value, it does look like they have that there. It looks like they did round that off to the, I can't see that. Let's see. Let me see. No, that's a different 878. Now that is something else. That's a critical value. Okay, and we're not making use of a crit because we're not using the table. We're not using the table. We're using the graphing calculator. So we actually don't need to make use of that critical value there because we're using a graphing calculator. So we're using the decision rule. Okay, and so and if you don't want to round, that's fine. But then you look at each place value. This is the ones place is tied. The tens place and right there you have an issue, right? They're different. This is a 3 in the tens place. This is a 0. So is that true or false? Is 3 a number that's less than or equal to 0? No. No, 3 is not less than or equal to 0. That's false. So it looks like this one's false, and that means that the second one in your decision was going to be true. That means this one should be true. Okay, so if I look at this one, I look at the ones place, they're tied. I look at the tens place, and I see, yeah, this is 3 and this is 0. And is that true or false? Is 3 a number that's greater than 0? That's true. So you have to know your inequality symbols. This symbol means greater than. You have to know your inequality symbols. This symbol here means this symbol here means less than or equal to. So you do have to know your inequality symbols, okay? So this is true. 3 is greater than 0. Okay, so then what did that say? What did that say? So you go to your handout, you go to your notes. Where are my notes? Let's see. Go to that handout where we had the decision rule, and we're saying that both of these cannot be true. Only one of these can be true. So we found that the second one was true. So what does that say? Do not reject the null hypothesis. If you're going with this, if this is the one that's true, then do not reject the null hypothesis. So I write that down. Okay, do not reject the null hypothesis. Okay, so then we're going to go with that. Do not reject the null hypothesis. Now, and so what does that mean about, we're trying to decide on the relationship. So so now we come to the next page where you summarize your results. Okay, and you summarize your results. And this is one we're interested in because when the decision is made to not reject the null hypothesis, see, that's what we said. Do not reject the null hypothesis. What does that mean? So H sub 0, the null, because why would you do that? Because the probability value is greater than the alpha value. See, and that's what happened here. This value, the probability value, was greater than the alpha value. Okay, and what else does that mean? We summarize the results by saying that there's not enough evidence to reject the claim. Okay, so what else does that mean as far as our variables, our x and our y variables? What does that mean? So in other words, we do not reject the null hypothesis h of 0. um, then we summarize that there is not a significant relationship between the x and y variables, and that's the summary right here. And I don't think I have to rewrite it, but I will put summary here, and I'm going to highlight that in yellow, and that is going to be this part here. This is let me make this larger. Give a brief explanation of the type of relationship. Okay, and so we're saying this then. So we're saying this: do not reject. There is insufficient evidence to conclude a linear relationship exists between the x and the y variables. The x is the per capita depth, and then the y is the tax. So remember, we saw that over here, remember? X and Y, per capita depth, and the per capita tax. Okay, so we have that here. All right, and that's our summary. So on the quiz and on your homework, I believe it'll have both write-ups, like there is a relationship or there's not a relationship, and in this case you want to click on, because you're not rejecting, do not reject the null, you're summarizing that um, that 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 there's not a relationship. Do not reject. There is insufficient evidence to conclude a linear relationship exists. Yeah, so you cannot say that there's a relationship that exists between the variables. And that's kind of the theme, right, that was going on all along. We started with a scatter plot. Remember the scatter plot? So go back on and hit graph. Remember the scatter plot? Um, and so that it wasn't really quite going through the points. It looks like it zoned in. It looks like it's going through at least one point, but that's still not strong enough. 1 point to go through that, you want to go to at least 2 or 3 points, right? So that wasn't strong enough there. And then you saw the R value was a little bit weak, right? 0.5, so it's kind of in between. So you were kind of leaning towards not being a relationship between the variables, and then you clinch that with the decision rule. You use a decision rule, and that clinched that thought. Okay. All right. Okay. So work on your homework. Work on your homework for 10.1. And if you need any tutoring, remember our math row. Hopefully after you watch the video and then you start working on your homework, you'll do fine. But if you do need tutoring, then you do need to go to our Math Row tutoring. I have a link in your Canvas course under Math Row, like virtual join Zoom links, right? So you want to the go-to person is Trudy, Mrs. Hurd, Trudy Hurd. And only because she's sat in our stat courses, she sat in several of my sections of my stat course, so that she could readily tutor somebody. So they are working from home during this remote um, session and with COVID-19. So they are working. They're just working from home, and but all they do all day is tutor and answer your questions, and they help support the faculty and of course the students. Okay, so we're open almost every day of the week except Sundays, and they do close early on Fridays and Saturdays. I think they close at 2 o'clock, I think. And but other than that, during the week, Monday through Thursday, they're open till 7 o'clock at night. Okay, so you need to hop on to that Zoom link and then look for a stats tutor, and then seek some help. But hopefully with the videos, you should be able to grasp the knowledge, and then reading the ebook and working on your problems. Okay? All right. Okay, so good luck with that.